Hello, my name is Andrew Cameron. I'm a postdoctoral researcher working with the Swinburne University of Technology and also with Osgrav. And my poster describes a long-term study of two long spin period eclipsing binary pulsars found in the high time resolution universe Southern Galactic Plane Pulsar Survey. Now, why are we interested in these pulsars? Well, only about 11% of all the pulsars we know about so far, nearly 3,000 of them, are found in binary systems. And of those, about 80% of them are found in what we call recycled binary systems. The pulsars have been spun up to very rapid rates of rotation by accreting material from their binary companions, and they're a very well-studied class of pulsar. But long spin period pulsars with spin periods of hundreds of milliseconds to over a second are much rarer and represent a bit of a gap in our knowledge, as we don't have many examples to work from to figure out how these kinds of pulsar binary systems form and evolve with time and how they fit in with the overall picture of pulsar evolution. So in this poster, I describe the work that I've done over the last 5 or so years on two such long spin period binary pulsars that I've been studying since I discovered them during my doctoral research back around 2016. The first of these is pulsar J1653-45, which is a 951 millisecond pulsar in a 1.5-year orbit, a very eccentric orbit, around a companion of about 3.9 solar masses. And it's one of a class of roughly half a dozen pulsars that show very similar properties: eccentric orbits, heavy companions, long orbital periods on the order of years, and most crucially, eclipses. Now, you can see in the bottom right of this poster the tracking that we've done on this pulsar with the Parkes telescope, watching its changing apparent spin period over the course of several orbital cycles. But our knowledge of the pulsar's orbit has been restricted by the fact that we can't see it during a roughly 40 to 140 day eclipse right around periastron, where the orbit becomes its most extreme. And that's meant we haven't been able to figure out the orbital properties of this pulsar, preventing us from really doing a detailed study. The poster describes some recent breakthroughs we've made, including a refined position thanks to observations with the compact array, and the identification of a possible stellar companion that may be linked to the pulsar that we're currently trying to confirm. And also we are working to observe the pulsar during its most recent eclipse with new observations with the Parkes telescope, and we've made a few breakthroughs there as well. The other pulsar on the right-hand side of this is pulsar J1812-15, which is a different kind of pulsar. It's still long spin period, it's about a second in rotation, but its orbit's only about 20.3 hours long, and it shows an eclipsing variability, this time likely due to an intrabinary debris cloud. This pulsar has a really weird mix of properties. It has a short orbital period, and it has the intrabinary debris cloud, which would be expected of a Black Widow pulsar, but the orbit is very circular, and the companion's about half a solar mass, which would be expected of a different kind of recycled binary pulsar. Yet the pulsar is long spin period, and it's not recycled at all. In fact, in the entire catalog of all 3,000 pulsars we know about, roughly, there's only one other pulsar that even looks anything like this, B1718-19, and that one's been quite well studied. But a lot of its formation scenarios revolve around the fact that it's part of a globular cluster, whereas our pulsar has no globular cluster association whatsoever. So working out what's going on with this pulsar will hopefully shed some light onto how both of these pulsars have come about and what the differences are between them. So please have a look at my poster, and if you see me around the space, please feel free to come and talk to me about it. Thank you very much.